Yeah, so first thing you need to do when you're solving this is first thing, you need to have a calculator, you need to take a notebook, and obviously something to write with, a pen or a pencil. So make sure that you have that right now. We will be solving many questions. So make sure that you have that. If you need a minute, go on, get that. Okay, so I'm assuming you have that. So the first thing we need to know is what standard form is. So standard form is used in many calculations. So standard form is when you have the decimal point after the first no significant digit. So what have I said? The decimal point after the first significant digit. So what is a significant digit? It's any non-zero digit from the left side. So from the left side, the first non-zero digit you get, that is standard. That is the significant number. So let me give you an example. Let's suppose I have this number. So this one is not in standard form because the first significant number is this one. So I need the decimal point all the way over here. So to do that, I will have to move it 1, 2, and 3 steps. So the standard form of this thing would be 2.4783. But the problem is that 2478.3 is not the same as 2.4783. What do I need to do? I need to show that I have moved the decimal point. So I will multiply it by 10 power something. Why 10? Because we're dealing in decimal number. This is a decimal point. So how many steps have I moved it to the left? I have moved it 3 steps to the left. So if I want to bring it back, I need to move it 3 steps to the right. So that's why I'm writing +3. That if you want to bring it back, move it 3 to the right. Okay, so that's how it goes. So if you're moving to the left, you put a positive number. Okay, so this is standard form. Similarly, if I had something like this, 0.00385, and this is not in standard form. So if I wanted to bring it to standard form, then I will need to move this 1, 2, and 3. Why? Because this is my significant number. So this will be 3.85. But how many steps have I moved it? 1, 2, 3. So if you're moving it to the right, you put -3. Okay, so now that that's done, tell me what is the standard form of this number, this number, this number, this, and this. Okay, go on, solve it. All right, so how do we solve it? We just have to look at which is the significant number. So this is the significant number, this is the significant number, this is the significant number, this one is, and this one is. Okay, now we have to see how many steps do we have to move. So once you have the significant number, just write that. So 2.3578, 4.376, 1.69, 3.45, and 6.72891. But obviously we are not done yet. We need to show it how many powers of 10 we are moving. So for that, this one is moving 1, 2, 3, 4. 4 steps to the left. So that's why it's 4. This one is moving 1, 2, 2 steps to the left. So this one is 2. 1, 2 to the right. So this is -2. This is 1, 2, 3, 4. 4 to the right. So that is -4. And again, 1, 2, 3, 4, 5. 5 to the left. So that is +5. Okay, so those are the standard forms. All right, so now I'm going to write some numbers. And what you have to do is you have to multiply by 237, whatever number I write, and then tell me your answer in standard form. So I'm assuming you have a calculator now. So go on, multiply it by 237 and give your answer in standard form. Okay, so 246.8, that's the first one. Okay, go on. Multiply 237 with each of these and give me your answer in standard form. So let's do it. The first one, if I want to do that, so it is 246.8 and I'm multiplying by 237. This will equal 56,121. Second one is this. Third one, 267.831. This is going with this. and this one is 0.051 times 237, and this one is 5.67 times this, and there you go. So we have these numbers. Now, obviously, I'm using the built-in calculator here, but these are not in standard form. So to bring it to standard form, what will I have to do? I'll have to move the decimal point. So this is 56,121.6. So let me zoom in a little bit. Yeah. So this one, I need to move it 3 steps to the right. So the first thing I need to know is what's my significant digit. This one is, this one is, this one is, this one is, and this one is. So how many steps do I have to move here? So 5.61216, 2.661510, 6.3475947, 1.2087, and 1.34379. Okay, so times 10, all of them. How many steps? So this one, I'm moving 1, 2, 3, 4. 4 steps to the right, so that is plus 4. This is 1, 2, 3, 4, 5, 6 to the right, so plus 6. This is 1, 2, 3, 4, 4 to the right, so that's plus 4. This is 1 to the right, so just 10 power 1, or you could just leave it like that, and 1, 2, 3, so this is plus 3. So as you can see, they're all written like that. But the thing is, you usually don't have to write numbers with so many digits in them. We do what is called approximation. So what we do is we approximate these numbers to 3 significant figures. And that's how you give your final answer in O-levels or IGCSE. You write them to 3 significant figures. So let's go back to our first one. What is the third significant digit? So the third significant digit in this case is 7, because 1, 2, 3. So we have to approximate at 7. We don't have to approximate 7, we have to approximate at 7. So we look at the next one, which is greater than 5. So it will be 2.48 times 10 power 3. Okay, because what we had to do was approximate the number at the 4th position. जब आप third significant को round off कर रहे हो, तो आप 4th पे जाते हो. Similarly, this one is already to 3 significant figures. We just have 3 digits, so that's good enough. Let's look at this one. What is the third significant digit? Over here is this, over here is this, over here is this, this. Okay, so let's approximate them. So this one will become 2.36, because the next one at the 4th position is 7, greater than 5. This one will be 4.38. This one will be already is to 3 significant digits, so that's good enough. This one's also to 3, so it is this. And this one will be 6.73 times 10 power 5. We are not making it a 0, we're just approximating it to third significant figure. Now, what do you do if you have 5 in the next one? So for example, if I had 1.625 and I want to approximate it to 3 significant figures. So let me look at this. I have these two. So both of them will approximate to 1.62. And the reason is that if you look at the third digit, this is 2, this is 1. If the next digit is 5, you make this even. Okay, so that's the rule. If you have the next digit as 5, you make it even. So 1.625 will become 1.62, but 1.615 will also become 1.62 because 1 is not even. You make it even by adding 1. So you only add 1 when you have an odd number here. So this is odd, you make it even, so it becomes 1.62. So that is how you approximate. The next thing that we need to understand when we are solving these questions is MR and percentage composition. So MR and percentage composition. This is important when we want to figure out how to make a compound or how much anything we can extract from a compound. So let's suppose we start with a really simple example, SO2. So what's the MR? MR is when you add up all the relative masses of every element there. So there's 1 sulfur. So the first thing you need to do is you need to list down all the atoms that there are. So 1 sulfur, 2 oxygen. Okay. Sulfur is 16. I know it from from the periodic table. 1 sulfur, sorry, the proton number is 16. Let me see what's the mass number. So AR, which is relative atomic mass of sulfur, that is Let me see. 32.1. So I'll just use 32 because in O levels we usually just go for chlorine goes in the decimal. Plus 2 times 16 for oxygen. So that gives me 64 as my total mass. Now, what is the percentage composition? Percentage composition is how much of sulfur there is in the whole thing and how much oxygen there is in the whole thing. So for sulfur, so percentage of sulfur and percentage of oxygen, let me see. So out of this 64, the total is 64, you have 32 as sulfur. So this you multiply by 100%, and that's how you do it. So this one is also 32, so 32 over 64 times 100%, so that is 50%. The ratio method is also very useful there. So you can say that, all right, 64 is the 100%. So in the case of sulfur, we have 32 for sulfur, so that is X%. So you cross multiply and you'll get X equal to 50%. Similarly, in the case of oxygen here, we know that 64 is the total, which is 100%. 32 is oxygen, so that is X%. So X comes out to be 50% again. Now, this was a unique example because quite a special example because sulfur and oxygen were two things that were both in the same quantity. But that's not always the case. Let's try to do it for magnesium carbonate. So let's suppose we do magnesium carbonate. So this one is MgCO3. Let me get a better color. Yeah. Okay, so magnesium carbonate, the first thing we need to know for MR is we add up all the atoms. So 1 magnesium, 1 carbon, 3 oxygen. Magnesium is 24, carbon is 12, oxygen is 16. So we add up all of that. So that gives us, so what is it? 24 plus 12 plus 3 times 16. That is equal to 84. So we have 84 as the relative mass. It is the mass compared to carbon 12, 1/12 of carbon 12 for this magnesium carbonate. Okay, we have 3 elements here. So magnesium, carbon, oxygen. So what's for magnesium? You have, so if you're using the formula, you have 84 as the total mass. So all of them, 84 is the total. And for magnesium, you have 24 for magnesium. For carbon, it's 12. And for oxygen, is this 3 times 16, which is 48 by the way. So you put it in a calculator and you will get your answers. Okay. So if you do that here, so 24 divided by 84, that is 0.85287. So I'll just write this 28.6%. Similarly, 12 out of 84 is 0.1428. So I'll just write 14.3%. And the last one, there are 2 ways of finding that out. Either you do 48 over 84 times 100%, or what you can do is you can add up 28 and 28.6 and subtract that from the calculator. So that is 71.4, and then 71.4 minus, what's this number? 14.3. So 71.4 minus 14.3, that is 57.1. So there are 2 ways. Either you do the formula or you just add them up and subtract from 100%. And that gives you 57.1%. One way to know that you have done it right is you add up all of them. So 28.6 plus 14.3 plus 57.1. And that should give you 100% for the whole thing. Now, sometimes we get water as part of this crystal or something. So for example, if I had sodium carbonate and that has this thing written alongside. So what does it mean? It means it's the water of crystallization. So this thing is water of crystallization. It is what allows it to make crystals, okay? So water acts as a glue, bringing these sodium carbonate formula units together, making crystals. So you have 10 water molecules. So when you're taking the MR of this thing, you need to account for that. Now, water is a fairly simple substance that we use so many times. So water, ammonia, sulfuric acid, these are the ones that we use so many times that usually you will see that when you do these calculations, you will eventually memorize the MR of these. Automatically ho jayega. So this is 18, this is 17, this is 98, this is 100. Automatically ho jata hai. Nahi bhi hota to you can always calculate. So you have 2 sodium, 1 carbon, 3 oxygen, and you have 10 water. Now, why am I saying 10 water? Because I don't want to separate it as 20 hydrogen, 10 oxygen, because mujhe water ka automatically yaad hai ki wo 18. So I can just put the other numbers there. So 2 times 23 plus 12 plus 3 times 16 plus 10 times 18 because that's water. And that is how I will get my answer. So I just have to calculate it all. So this is 46 plus 48 plus 180 for water, and then you have 12 for carbon. So 286, and that's my answer. So this is 286. Now, if I want to find out the amount of every substance, so I'll do it for sodium, I'll do it for carbon, I'll do it for oxygen, but I'll also do it for water because water is not part of the compound. It's actually part of the whole crystal. So I need to make sure that how much water is there. Usually we find that out through experimental setup ke kitna water molecule hai, kitna percent of water, and usually in paper 4 there are questions on this, and we will solve some of them. So let's do it. So the method is still the same. You have 46 of sodium divided by total 286. You have 12 of carbon, so divided by 286. You have 48 of oxygen divided by 286, and you have 180 water, so 180 over 286. You multiply it all by 100%, and you will figure out what your percentage composition of this thing is. So this is a fairly straightforward question, and you can easily solve these questions. Okay, so percentage composition, and this, I hope you understand how to solve it. Why is this useful? This is useful because number one, we needed to calculate the empirical formula. And number two, we use it to figure out how much of water we can extract from something, or how much of a metal we can extract from its ore, or something like that. Examiner sometimes uses this to quiz you. So for example, if you said that we have 2 tons of aluminium oxide and we are electrolyzing it. We have talked about this process that you electrolyze aluminium oxide to get aluminium. So how much aluminium can be extracted? So how do we do a question like this? So the first thing we need to know is that how much aluminium there is to get from aluminium oxide. So we can do it by percentage composition, or we can do it by ratio. So let me do it through both of them. Okay. So let me do it for aluminium. So now I'm not interested in oxygen. I'm just interested in aluminium. So I have 2 aluminium out of total 2 aluminium and 3 oxygen. So I'll put the numbers. Aluminium is 27. So 2 times 27. Interestingly, aluminium is the only metal so far that we haven't found. In fact, it is an element for which we haven't found an isotope other than the 27 one. So 2 times 27 plus 3 times 16. And now let's calculate. So this becomes 54 divided by 54 plus 48, 54 plus 48. And let me see, that comes out to be 0.5294. I multiply it by 100%, and that'll give me 52.94%. You'll notice that I did not round it off because I don't want to. I haven't found my final answer. I will round it off when I get my final answer. I will not round it off during the process, okay? So that means I have 52.94% of this thing is aluminium. So 52.94% of 2 tons is what I will get. So I'll simply do 0.5294 because 52.94% is 0.5294 times 2, and that is going to give me 1.0588 tons. I can round this off to 1.06 tons. So out of 2 tons, I will get this much aluminium. So we have solved this question, pretty easy question, right? The second thing where we need to use this is when we need to figure out the empirical mass. So how do you find the empirical mass? So for that, what you need to know is that you're given the percentage composition of anything, and then you use it to figure out the empirical mass. So they're saying there's a thing called, there's a thing that has 47% silicon. There's an oxide of silicon with 47% silicon. Find its empirical formula. So this is a pretty straightforward question. We have silicon, which is 47%, but we do not know how much is oxygen. But we also know that because it's an oxide, there's no other thing there. There's just oxygen. And if 100% is the total, then 53% is how much oxygen there is. Now, because we are dealing in ratios, we'll ignore the percentage sign because it's just there, cancels out. Okay. Now, the next thing you should do is divide them by their ARs. So 47 divided by silicon's AR. What is the AR for silicon? 28. So we'll divide this by 28 and this by 16. Why am I doing it for AR? Because I want to figure out the number of moles. And I will get to what mole is and all that tomorrow. For today, we just need to know how to solve this question. How to find the empirical formula. Okay, so this one is 47 divided by 28, and that is this. And this one is 53 divided by 16, which is this. So these are moles of silicon and moles of oxygen. So I found the moles. Now I want to find the mole ratio. Why? Because ratio is going to give me the empirical formula. Empirical formula has everything in the simplest ratio. So when I do that, I need to divide 1.6786 and 3.3125 by something that divides them both. In this case, I'll do it with the smaller number. So 1.6786 and this one also with 1.6786. This one is going to give me 1. This one's going to give me 2 point something. I'll round it off to 2. And there you go. I found my answer, SiO2. That's my empirical formula. Now, sometimes you don't get answers that are straightforward like that. So for that, you have to memorize a few fractions. So the fractions that you need to remember with the decimal approximation. So let me show. So if you get 1 by 2, then that is 0.5. So if you get 0.5, that's 1 by 2. That's pretty straightforward. Similarly, if you get 3 by 2, that is 1.5. If you get 5 by 2, that is 2.5. If you get 7 by 2, that is 3.5. What's happening here? So if you notice, the numerator here is 1, which is the first odd number, 3, which is the second odd number, 5, which is the third odd number, and so on and so forth, right? So we'll start counting. So first odd number is 0.5. 0 is the first number in the number line. Similarly, second odd number, you write 1. Third odd number, you write 2. Fourth odd number, you write 3. Another way to look at this or divide this is to convert it to a mixed fraction. So this is 1 whole 1 by 2. This is 2 whole 1 by 2. This is 3 whole 1 by 2. And 1 by 2 is 0.5. So just remember this portion. And whenever you get something like that, convert it to a mixed fraction. Mixed fractions are easy to convert. This is 1 and half. So this is 1.5. 2 and half. So that is 2.5. 3 and half. That is 3.5. So pretty straightforward. Similarly, let's do it for 1/3. So 1 by 3 is 0.333 and 3 goes on. So if I have 2 by 3, then that is simply 0.666 going on, or 0.667. Similarly, if I have 4 by 3, then that is 1 whole 1 by 3. So that's going to be 1.333. How am I doing that? I just need to remember these two. I just need to remember what 1 by 3 is and what 2 by 3 is. So if it is 1 whole 1 by 3, it is 1.33. Similarly, if I have 5 by 3, then that is 1 whole 2 by 3. So 1 is given, and then I use the 0.66. So 1.666. Similarly, if I have 7 by 3, that is 2 whole 1 by 3. So again, 2.333. Why am I doing this? Because sometimes we get these questions in the exam and you just get the decimal number, but you do not know how to convert it to this one. So it can get a little troubling or frustrating. So by remembering this one, and this one, you can figure that one out pretty easily. Similarly, for fourths, you need to know what 1/4 is, what 3/4 is. These two numbers are pretty simple. So this is 0.25 and this is 0.75. In fact, we can also remember it through fractions, through percentages, that this is 25%, this is 75%. 2/4 is obviously half, which is, we have already talked about it, 0.5. So just need to remember these for quarters. So 1/4, 3/4, and there you go. So this helps you convert this to a fraction pretty easily. So these are some things you need to remember. All right. So with that said, I'm going to give you a worksheet on empirical formula and a worksheet on finding the MR and percentage composition. So make sure that you do that. Also for tomorrow, because we will be moving on to equations and finding moles. So what do you need to remember for tomorrow? So what you need to remember is, number one, you need to be able to write formula of something from its name, and similarly write the name from the formula. That's something we talked about earlier, but if you haven't done the worksheet, make sure you do. Similarly, you need to know how to balance this equation. I will not be going over that tomorrow. This is something that I assume you already know. If you don't, it's always a good idea to practice. If you still have any problem, bring that to me. You can always contact me and I will help you out in that. All right. So tomorrow we will be talking about how to find mole, how to use mole, and how we can use equations to do that. All right.